Right, I'm going to show you how a plug works. So the learning objectives are basically know the parts of a plug and what they do. So you've got 3 wires, okay? You've got this big main white wire on the outside. It's what you call a 3-core wire because there's 3 smaller wires inside. So you've got to know the names of the wire, what they do, and which pin they go to. Because with a plug there's 3 pins. Now the earth wire is for safety. It stops the metal casing of an appliance becoming live. I'll do a full video to do with the earth wire because you do need to know quite a bit of detail. The earth wire is green and yellow. So if you look, the green and yellow wire's here and it goes to the top pin. Now, this screw here is connected to this pin. So this is the top pin. Now, you've got the blue wire coming over to the left, right? Blue goes to the left, right? That works quite well, doesn't it? Look at this. The brown wire goes to the right. So the live wire, which is the brown one, now that one carries current and voltage into the appliance. So that's this one here. And the neutral wire, the blue one, that carries the current away from the appliance. It completes the circuit. Now you get the same size current in the neutral wire as what you do in the live wire, but it's got 0 voltage. Now remember that voltage is electrical energy and the appliance has used the energy. So what I mean by that, this plug needs to be plugged into that socket. So the top pin gets plugged in to that top hole. The left hand pin, that gets plugged into the left hole, and the right hand pin, which will be there, gets plugged in to the right hole. So if you're looking at the plug like this left hand pin is actually that on the right, because it's back to front, isn't it? The top pin is obviously that. And this right hand pin, that is actually this. So just imagine turning that around and then taking this back off. Right, this is the plug with the back off. So if you're talking about the left pin, they mean the left pin when the back's off. If you're looking at it as if you're just about to plug it into the actual socket. Now, because the live wire, the brown one's the dangerous one, it has to be connected to a safety device. Now that's what this fuse is. It's got a rating on it. You cannot see the rating because it's turned around, but that might be like a 13 amp fuse. I'll tell you more about fuses in another lesson. Now the last thing that you need to know about is the cable grip. So this thing here is the cable grip. It's just a piece of plastic that is literally gripping the cable. Now make sure that you've got it gripped across the outer insulation, the outer part of the cable, not the 3 skinny inner core cables. So there's your earth. Now they call that wire the earth because it's connected to the earth in the hope that the voltage would get spread out across the earth, and the earth's that big that the electricity would just discharge to nothing and no one will get a shock. There's the neutral wire. And there's your live wire there. Now let us show you what I mean by the live wire bringing the current into the appliance and the neutral wire taking it back out. Now imagine you had a telly, right? Imagine here's your TV. To make the TV work, we need electricity to go in and come back out and be a complete loop. The live wire is the right hand pin. So the current comes out of the live wire and goes into your telly. And then to complete the circuit, the neutral wire takes the current back to the socket. Now this switch is connected to the live wire. So again, that's just for safety, so you can turn the electric current on and off. Now the way that I like to teach my students about electric current is I like to think of it as being these like little Ribena men, these little electrons, and they've got energy. So they're all marching along down here, if you like, and they've got voltage. V for voltage. Now they're going to drop the voltage off at the TV, so that electrical energy is going to get converted into light energy and sound energy. That's what you want out of your telly, isn't it? You want to see the picture, so there's your light energy, and you want to hear it, so that's your sound energy. Now those little electrons have got to go back up through the neutral wire. Now the thing is they don't have any voltage because they've used it. So if you get asked what is the voltage of the live wire, you can say it's 230 volts. That's in England. And then if they say what's the voltage of the neutral wire, that's at 0 volts because the voltage is being used up. Now this cable grip here, it's for safety. It stops some little baby or whatever coming along and yanking on that wire, and if these screws are not tight enough, all of these wires would get yanked out if this wasn't here, and then that would expose the live wire, and if someone touched it, they'd get a shock and it could kill them. So the cable grip secures the cable into the plug head to stop the cable being ripped out of the plug, and the cable grip must go across the outer thick cable, the white part here. Now what else might you get asked? Well, I've saw in the past examiners ask what these 3 pins are made from, and what these wires are made from, what the plug head's made from, and even what's the socket made from. So let us quickly go over that. The 3 pins are made from brass, and that's because brass is a good conductor, but also it's tougher than copper, because you might say, well, why not make them out of copper? Right, copper pins would actually bend, because copper is quite bendy. And then you might say, well, why not make them out of steel? Well, yeah, steel's a good conductor, and it's tough, it doesn't bend, it's stiff. However, steel rusts. So we use brass because brass doesn't rust. So that's a couple of good reasons why we use the brass. If you get asked what about the wires? Well, you say that the wires are made from copper. Why is that? Well, because it's flexible and it's an excellent conductor. So there's 2 reasons for that. The reason it's got to be flexible is because the wires have to be able to bend. And also, if you've got wires on any component, like your telly or something, the wires have to be able to bend around your TV cabinet and all that type of stuff. Now, they might ask you, why is there insulation around the copper wires? Well, the wires are wrapped in flexible plastic because they need to be able to bend, right? So it has to be flexible plastic. It needs to be able to bend around the corners from your telly to the plug socket. But also, they use plastic because plastic is an insulator. What about the plug head? Well, the plug head and the main socket, so this over here, they are made from stiff, hard plastic. Plastic so that it insulates something, and it's stiff so that it lasts a long time and doesn't crack easily. Can you imagine if you tried to put these pins into here, right? You try to put your plug in and you miss the hole by accident, and if you were to put dents in it, your socket wouldn't last for very long, would it? So this plastic has to be stiff. Likewise, the plug head itself has to be made from stiff plastic. And that's just telling you about the cable grip, but I've already told you what the cable grip does. And that's basically it. So I'll do another video to tell you more about the earth wire and the fuse, and also circuit breakers. Oh, and here's a quick question. If I'm going to do a few videos of this style, would you prefer that I draw on a white background, or would you prefer that I draw on a black background? Just in case you're watching it on a night time in your bed, I don't want it blinding your eyeballs. Right, work hard, Be nice. Ta-ra for now.